Dear students, already you are completed module number 3 in online class and with quiz also. And this online module number 3 is operation amplifier and applications. Now we will be next going to discuss the module number 4 for basic electronics, BJT applications, feedback amplifiers and oscillator. In the module number 4, there are 3 parts using our different aspects. First one is BJT applications, bipolar junction transistors. Second one, amplifiers, that is feedback amplifiers. And third one, oscillators. This is the module number 4. And you are going to discuss for one by one in this. First is BJT as an amplifier. The second one is BJT as a switch. And third one is applications using transistor, switch circuit to switch on off and LED, and a lamp in a power circuit using relay. This is application using a transistor, how LED will be glow for using of transistor. Now will be first is what is the distinct transistor. The transistor is defined as transfer the resistor. The trans plus resistor is equal to transistor. And transistor is very important to use the aspects for using the how apply the signal for the low signal to the high signal using of transistors. Here there are two types. One is the NPN transistor, second one is PNP transistor. And this NPN and PNP transistors, these two symbol is used. Okay. This is the NPN transistor symbol. This is the PNP transistor symbol. In this NPN transistor, the three terminals, emitter, base, collector. This is the notch for using of NPN, and this side is notch using of PNP. And this is a simple circuit of NPN transistor, NPN, using of emitter, base, collector. Supply the current, emitter current, base current, collector current. Supply the voltage, VBE and VCB, base emitter voltage, collector base voltage. And this is the how circuit is used for all three terminals, emitter, base, collector. And apply the voltage base to collector VCB, apply the voltage base to emitter VBE, apply the voltage collector to emitter VCE, VCB, VBE, VCE, that is voltage. Apply the collector current, collector side, base current, base side, emitter current. Apply the both current and voltage in all three terminals. And same thing here also, PNP transistor. And reverse voltage, what applied voltage here, same reverse voltage of the here. And same apply the voltage and current for NPN and PNP transistor. Next is very important use for the BJT as an amplifier. BJT, bipolar junction transistor. What is the BJT? Bipolar. Bipolar means two signals applied in the signal. The AC input voltage produces a base current which results in which larger AC collector current. The AC collector current produces AC voltage across RC. It is producing an amplified signal, but inverted reproduction of the AC input voltage. You apply the AC input voltage for here for using the input side, for the input voltage for the using of AC input voltage, base resistor, collector resistor, applying in this. Okay, here two voltages applying for the collector side, collector voltage, one voltage using base voltage, input to the output. In this circuit, this is the circuit diagram of transistor circuit using a bipolar junction. This circuit diagram is bipolar junction transistor. This is very important. Sometimes they ask, explain with neat circuit diagram BJT as an amplifier. This is the only one circuit diagram of in this module for transistor about apply the input voltage for and output voltage is inverted of this. AC input voltage and output voltage is inverted. For inverted means inverted of this signal. In this, to find the gain, for in this transistor find the gain. What is the gain? Already know the ratio of output voltage to the input voltage. This is the input side, this is the output side. What is the input side? Input side is VB and output side is VE. Then what are the equation will become of in this circuit? In this circuit, for the what is the VB? VB base voltage, VC is collector voltage. VB is equal to IE into RE dash. This VB is equal to emitter current into this voltage RE dash. The next VC is equal to RC into RC. That is this VC is equal to collector current into this. VC is equal to IC into RC. Therefore, IC is equal to IE. The collector voltage is, therefore VC is equal to IE into RC. In this voltage, Vc can be considered the transistor, the AC input voltage, where Vb is equal to Vs minus Ib into Rb. In this circuit, the ratio of the voltage gain is defined as the ratio of the output voltage to the input voltage. The ratio of Vc to Vb is the AC input voltage. Therefore, the gain of the transistor is, what is the gain of the transistor? Vc divided by Vb. Therefore, AB is equal to Vc by Vb. And what is the Vc? IE into Rc. Vb is IE into Rd. These two equations substitute in this equation. Substituting IE Rc for Vc, IE Re dash for Vb. Therefore, AB is equal to Vc by Vb, but Vc is IC Rc and Vb is IE into Rd. ICC get cancelled. Therefore, the gain of the transistor is AB is equal to RC divided by Re dash. This equation is very important for what is a BJT as an amplifier. The gain of the amplifier, the gain of this full circuit amplifier is, therefore AB is equal to RC by Re dash. This is the BJT of an amplifier, first transistor. Next, this is one problem for using the transistor circuit. This is one problem for the determine the voltage gain and the AC output voltage of in this figure. In this is everything is given. Vb is given 100 millivolt, Rc is given 1 kilo ohm, and Vcc is supply voltage. What is the our formula? What is the voltage gain? Gain is AB is equal to Rc divided by Re dash. That is Rc is given 1 kilo ohm, Re dash is given 50 ohm. That is 20. AB is equal to 20. Therefore, the AC output voltage is equal to AB into Rb. But already AB is there. That AB is equal to 20 and Vb is equal to, the Vb is given 100 millivolt. That is 2 volt RMS value. This is the one problem of transistor. Next, switch. In this BJT switch, bipolar junction as a switch. How the BJT using of a switch? In this there are two parts. One is the cutoff, one is a saturation. Cutoff is open switch, saturation is close switch. Open switch and second one is close switch. Switch means on off button. When it is on, current will be flowing. When it is off, current is not flowing. In this there are one circuit is using for the one, basically one circuit is a transistor, NPN transistor. RB, RC is using IB is equal to 0 and IC is equal to 0. Applying the voltage 0 volt here, because here is this is an open switch, open circuit, plus VCC and ground, RC, collector and emitter. Collector and emitter as the open switch means there is no current flow in the circuit. This is the cutoff, open switch. There is no current flow in the circuit. And next is saturation. Saturation is a closed switch. Collector and emitter, it is a close. There is a current flowing circuit. There is a current flowing in the circuit. Therefore, circuit will be on. The LED will be glow. This is a closed switch. It is known as saturation. Open switch, it is known as cutoff. This is open and closed switch. It is a using of transistor. Next, you will be discussing of for both cutoff and saturation. Next, what is a cutoff switch? A transistor is in cutoff region when the base emitter junction is in forward bias, neglecting the leakage current. All of the currents are 0 and Vc is equal to Vcc. Vc cutoff is equal to Vcc directly. Vc is equal to Vcc because there is no current in the flowing circuit. Directly Vc is equal to Vcc. Next, condition is saturation means closed. When the base emitter junction is forward bias, there is enough base current to produce maximum collector current. The transistor is saturated. The formula for the collector current is IC is equal to Vcc minus Vc divided by Rc. Therefore, the minimum value of the base needed produce saturation is Ib is equal to Ic divided by beta into Dc. Ib should be significantly greater than the Ib to ensure that the transistor is saturated. There are two is a switch, BJT as a switch. One is a cutoff, second is a saturation. That is, if it is a cutoff, directly Vcc is equal to Vce. Here is current flow in the circuit, that is a saturation. This is a BJT as a switch. This is very important. Somebody has explained how transistor is as a switch. Okay. Next, applications. One simple application is a transistor switch. That is how LED will be glow. This is a circuit diagram of transistor switch. For here, in this transistor, this is a basic transistor switch, NPN transistor. The RB is a base resistor, RC is the collector resistor and supply the voltage VCC. And this is the one LED is applying for between for collector side applying the one LED. How this LED will be glow? If LED is glow, the current flow in the circuit. If LED is on, there is no current flow in the circuit. Here is using of input is square wave. On off. This is on off. Again on and off. If it is on, that is a 1. If it is off, it is a 0. Means low, high. If it is on, there is a current flow in the circuit. LED will be glow. If it is off, there is no current in the flow circuit. That is off. The transistor switch, it is a LED. Applying the square wave. The square wave is at 0 volt. The transistor is cut off, and since there is no collector current, the LED does not emit. Means there is no LED will not glow. When the square wave goes to high level, the transistor is saturates. This forward bias in the LED and the resulting collector current through the LED causes it to emit the light. The LED will be glow when it is on. The LED is in on for 1 second and off for 1 second. This is the application of a transistor switch. Today class will be discussed for the transistor.